Have you ever seen a perfectly healthy looking transformer running perfectly normal one day? And then suddenly it is failing catastrophically without any alarms, without any smell, without any visible warning. And this is not an imaginary story, this happens real life. Industries have faced this problem in real life. And most of the time, the culprit is something that has started before months or even before years, the partial discharge. And that is why it is super critical that you understand what partial discharge is and what are its different types. But before we go and talk about the different types of partial discharge, it is very important that you understand what partial discharge is. So first, let's talk on that. So imagine you have a pipe which is carrying water, and over the years it has developed a small crack on it. Now as a result, since of course this crack will not offer much of a resistance to the water flow, some part of the water will start coming out of that crack. But if you notice, the water that is coming out of this crack is not 100% of the water that is flowing through the pipe. It's just the partial amount of that. That is why we call it as the partial discharge. Now the same situation also occurs in the electrical system. Let me actually show that to you. So imagine we have a 145 kV cable, and on that cable you can see this black portion is basically the insulation part of that. Now of course this cable is under electrical stress, but due to the manufacturing defects in this insulation, we have some voids or some, let's say, impurities. And what will happen over time is because of this void, the electrical stresses will concentrate on that particular void. Why? Because it is offering less insulation or less resistance compared to the any other area on the cable. And as a result, all the electrical stress will concentrate on the void. Now, of course, the void is not infinite resistance, right? It has some of its own strength. But the stress, electrical stress is keep on increasing, and there will be a point where the dielectric strength of this void will fail, and eventually we will start noticing electrical discharge happening across that void. Now this discharge will not be a fully discharge, it will not break end to end yet. So it's just a partial discharge that is happening. And that's why the name is partial discharge. Let me actually show you one actual video of partial discharge. So this is a cable, and you can see there are, because of the voids there, the electrical discharge has started coming out. Now, is it breaking the whole insulation? Not yet. It is only happening partially. And that's why the name partial discharge. Well, in a simple terms, you can consider the partial discharge as a wooden beam with a lot of termites into that. From outside, it might look perfectly fine, absolutely healthy, but inside that wooden beam, the termites have already started doing their work. They have already started weakening the wooden beam. And one day, suddenly, without any warning, the whole beam will collapse. The partial discharge also works in the same way. From outside, the equipment might look perfectly fine, perfectly healthy. But inside, the partial discharge has already started weakening the insulation. So you can say the partial discharge is the termites for electrical insulation. And one day, when the electrical insulation cannot take it anymore, it will collapse. The whole insulation system will damage, and there will be lot of issues that might occur because of that. And that's why it's very crucial to understand the different types of partial discharge also, because based on what kind of termites we have in our wooden beam, we have to do the medications, or you might spray some liquid on that to take care of that. In the same way, based on the type of the partial discharge, we will have to address that particular issue. That's why it's very important to you understand what are the different types of partial discharge that we have. Now, before we start understanding the different types of PD, a big shout out to Monitra. They are supporting today's video, and they have a very rich experience in partial discharge. So the actual real world case studies that you will see in this particular video, they are coming from the Monitra's very rich experience. We'll talk about Monitra and what they do later in this video. Now PD is classified into two major categories, the external partial discharge and the internal partial discharge. The external PD is further classified into corona partial discharge, or simply the corona discharge, and the surface partial discharge. Let us first start with the not so evil partial discharge, the Corona PD. If you ever walk near a 420 kV, 550 kV or 800 kV transmission line, you may hear some sort of hissing noise, or if you're traveling in the evening period, you will see even the violet glow. That basically is the Corona partial discharge. Now, this Corona PD is generally seen in the extra high voltage outdoor substations. Even the equipment that we use in that substation might face this particular issue. And also the extra high voltage transmission lines face the Corona problem. Now, why does this Corona partial discharge occur? Let's take one simple example of a bolt. Now, when you apply the voltage to this, an electrical field will be developed around this bolt. The field intensity is higher near the surface, like at the bottom of the bolt, and even this will be higher at the sharp edges. At lower voltages, this is not a problem. You won't notice anything. But the moment you start increasing the voltage, something happens. The air around the bolt starts to break down because air is not a perfect insulator and it contains a lot of free ions and electrons. And as a result, you will see a violet glow is coming out of the bolt, right? And now you may also hear a hissing noise. And this is nothing but the Corona partial discharge. Now, the voltage at which the Corona starts is what we refer to as the Corona inception voltage. The voltage at which the Corona starts. Now, the voltage at which it starts may vary based on the shape of the device that we are testing. So, if the device is sharper, the Corona might occur at earlier as well. So it varies based on the shape of the object. So how do we control this? The Corona is occurring because of the sharp edges, right? And we can eliminate that by using the Corona ring. So you can see a few examples here. These are the rings connected on the insulator of the extra high voltage transmission line. And these are the Corona rings you will most often see in extra high voltage substations connected to the different equipments that we use. For example, circuit breaker, disconnector, and other equipment. Now, what they are doing is they are providing a smooth round shaped surface to electrical stress that will reduce the intensity of electrical stress, and we may not have the Corona discharge. So that's the simple solution. For transmission line, you will see we use bundled conductors. Now, when you bundle a lot of conductors together, the electrical stress that is coming out of them will be low and we will not have the Corona discharge. But if it happens, it definitely have some impact on the system. For example, one is the power loss. If it is happening across a very long transmission line, the power loss will be there. If the equipment and the bus bars are nearby, it will also create a sparking between these two. And maybe if the voltage increases, that gap can be fully breached and a failure might occur. It interacts with the communication line, which is not good because you will have disturbances in the communication signal because of that. And it also generates the ozone gas, which further degrades the strength of the insulation. So definitely it is not good, and that's why we should avoid. But the good part of the Corona partial discharge is it can be detected very easily. You can hear the hissing noise, you can see the violet glow, and you can take the immediate action on that. So compared to what is coming next, you can say this Corona or this type of partial discharge is less evil. And before we go to the next type of Corona discharge, if you're finding this video helpful and if you love such kind of videos, definitely do subscribe to the channel. That will for sure help the channel to grow further and reach more and more audience. Thank you for that in advance. Now let's talk about something that is far more dangerous than Corona. Now, let me actually share you a real world case study. This is done by the Monitora. One of the pharmaceutical company in UK had a lot of transformer, 11 kV dry type transformer in combination of 1.6 MVA, somewhere 2 MVA, and different ratings were there. Now they were placed in ideal environmental condition. You can say clean environment, humidity is under control, temperature is under control. So kind of ideal situation for the type of transformer they were using. As a part of preventive maintenance activity, they decided to do the online partial discharge monitoring. For that, Monitora helped them in carrying out the testing. And to carry out this test, they used a handheld portable device like the one you see on the screen. Now, when they tested each and every transformer with this device, they found most of the transformer were showing, normal readings, but one transformer had a very high PD activities. And the good part is company listened to them and they took out the transformer from the service. And when they inspected the transformer, they identified something is not right with one of the bushing. They identified some marks on the bushing. And when they zoomed in, they noticed there was some conductive paths that are getting created. The insulation surface had developed tree-like conductive paths, and this transformer was very near to a flashover. So what is this? This is not a ghosted or haunted bushing, right? It may look like that, but it's not something that is done by the ghost. It is done by the partial discharge. This type of partial discharge where the surface tracking happens is called surface partial discharge. Now the question is why this happens. There are multiple reasons. Let's talk about them. First, it can be because of the surface contamination. We may have problem there, or maybe in the improper installations, the right installation methods were not followed. Could be the manufacturing defects. Aging of the insulation also contribute to this, or maybe the moisture and surface pollution. So when Monitra did study about this particular transformer, they identified the reason for this was the moisture content. Now this transformer were tested 6 months before. So 6 months before they didn't identify any problem with that. So within 6 months, this partial discharge was developed, and they took the transformer at the right moment. Otherwise it would have been a big issue. These transformers were in service for around 23 years. So aging was also playing, some role there. Now, once this surface discharge or surface PD starts, the discharge creates conductive tracks. Now, each discharge extends this path and until one day the complete failure occurs. Now, the surface PD is not only limited to the bushings that we talked about. It can very well happen to the paper insulation, dry type transformers, motors and generators, cable termination and bushings. And if you keep it unattended, it can definitely lead to a catastrophic failure. So the surface PD warns you, but only if you're looking for it.
If you have external or surface partial discharge, you'll find it on the surfaces of your high voltage insulators or the associated stress control regions. Most often these defects have been introduced at the time of installation or during some improper maintenance activity or contamination problems during operation of the asset. Medium voltage switchgear is a common asset class in which we find surface PD. And the good news here is that we can use a simple handheld instrument in which we can survey the panels to find any PD problems. Once these have been identified, if they have been identified, then we can direct maintenance activities at those specific panels to correct the faults. Thereby, we can prevent unplanned outages and associated flashovers which are hazardous to our substation workers.
The next type of partial discharge that we are going to talk about gives absolutely no sign, and it's the most dangerous type of partial discharge that can happen. We talked about the corona partial discharge. We also talked about the surface partial discharge. Corona gives you a hissing noise, a visible indication while it glows, so it can be detected easily. Surface PD gives conductive tracks on the surface of the equipment which can be seen and can be detected. But the internal partial discharge absolutely gives nothing. No sound, no smell, no visual indication. And this is why internal partial discharge is also referred to as the silent destroyer of insulation system. Now let's understand why this occurs. Imagine we have a 24 kV insulator which looks perfectly fine from the outside. But while manufacturing, there have been some weak points, voids or impurities that left inside the insulator. Of course, this cannot be seen by the naked eye, so we don't know this. Now imagine we use this insulator to be placed on a 24 kV switchgear. Of course, this insulator will be under stress. 24 kilovolts is applied to that, and all the electrical stress will be attracted towards this particular voids because they offer less resistance. As a result, one day the dielectric strength of the voids will, won't be able to sustain the electrical stress that is happening on them, and the electrical stress will keep on weakening all this spot. And one day when the electrical field exceeds the void strength, the partial discharge starts inside the insulation. And the good part is you can't even notice that. Slowly each discharge damages the insulation until one day the complete breakdown occurs. It will not give you any visual indication, it will not give you any noise, it won't give you any surface tracking. Suddenly the failure happens. And that is why it is one of the most dangerous type of the partial discharge. Internal partial discharge can definitely lead to sudden and unexpected failure that will lead to, the damage of the major equipment in your substation, in your plant. And since your main equipment is damaged, you will have the complete shutdown. And complete shutdown means financial loss. And that's why if you notice or if you study the most catastrophic failures that have happened, most of them will lead back to the internal PD. The PD that you definitely cannot see. Now, some of the common causes of internal PD includes manufacturing defects, aging of the insulation, or improper process followed during the manufacturing process.
Internal PD occurs deep in the insulation system, where unseen it can cause severe damage. In rotating machines, internal PD is one of many common defects responsible for the failure of HV stator windings. PD sensors for these assets include coupling capacitors or HFCTs. The signals derived from these sensors generate what we call a PRPD pattern, and the interpretation of this pattern confirms internal discharges and differentiates from other PD sources such as surface tracking. When it comes to maintenance, the PD source type dictates the appropriate action. So therefore it's crucial to acquire and accurately classify the pattern itself.
Now we talked about the different types of PD and what they can cause, right? The failures can cause millions and millions. And that's why the first step to avoid them is to detect them, is to measure them. And if you want me to make a dedicated video in which I talk about how do we measure this partial discharge or how do we detect this partial discharge, then do comment measure in the comment section below. If I get enough comments, then for sure I'll be creating a dedicated video in which I talk about the different methods we use to measure the partial discharge. Now, before we end this video, a big shout out to Monitra. They are industry leaders in high voltage asset condition monitoring. They produce partial discharge diagnostic equipment and sensors and provide complete solution for PD testing and monitoring. So the case studies and all the examples that you saw in this video, the details were provided by the Monitra. I really appreciate their efforts in sharing the information with the larger audience. If you're interested in their products or want to get in touch with them, you can definitely check out the link that is given in the video description. Remember, if you want a dedicated video on how we measure the partial discharge, then do comment measure in the comment section below. Thank you so much for watching, guys. If this video helped you, then do like the video and do subscribe to the channel. Thank you for watching. I'll see you in the next one. But till then, keep watching, keep learning.